Challenger.
Welcome, guys and gals. This is your host, Frog Prince Rana, and thank you for dropping by. Well, what do you know? I reached a milestone. I have a response video to one of my videos. I am moving up the ladder. Now, I was obviously excited for, a challenge. I am a nerd gamer. But what did vex me was that his response video was for my video that, in my opinion, my best work when it comes to absolute logic and math. Pretty solid, I thought. Link to my video is obviously down below. And yes, if you have seen my other videos and thought they were view-worthy, then you should definitely check that video out. It is based on this old photo where you see the Blackpool Tower, then Irish Sea past that, and mountains from the distant Isle of Man. You will soon see that many of us had different ways to approach this photo. Exploring the Plane is responding to 4 such videos. Now, I have not seen the originals. From the clips presented in this, to me those made sense. So the full videos may have other points, but I'm focusing on the ones here. First clip shows how on a flat earth, Blackpool Tower has to be 3 times the height to appear as same height as Mount Sneffels in Isle of Man. Second clip is mine. I calculated what the visible height of that hill that we are seeing, which is 193 meters. With standard refraction over that distance, 396 meters should be hidden, which brings those hills' elevation to 589 meter height, which falls between North Barlow and Sneffels height. Third clip is saying on a flat earth, Isle of Man should be where the mark B is, and the reason it is not there is because of Earth's curvature. Final clip shows us 3D model of how this landmass would look on both flat and globe model. How about the responses?
This diagram may look convincing at first, but it's just not how vision works. First, it has no concept of angular size. That's to say that objects become smaller proportionally with distance, and whilst there are problems with the angular size argument, we should at least have a notion of it, which this diagram is missing. He proceeds to calculate the hidden height of the mountains based on pixel heights compared to Blackpool Tower and concludes that this is perfectly possible on a globe Earth with standard refraction. He simply states that standard refraction is fact, and his previous video, which he refers to, doesn't contain any compelling arguments for it.
Sorry guys, atmospheric refraction is a fact. If I remember, I will try to link my previous video talking about this with many examples. From top of my head, twinkling stars, color when sun is near horizon. On that video, I also explain how this all supports atmospheric refraction.
His conclusion is that standard refraction accounts for the discrepancy. So again, the propaganda which is subtly being pushed here is that a little downward refraction, or looming, which is apparently capable of pulling mountain ranges up hundreds of feet, takes care of everything and is something that we should accept as the normal state of affairs. As just discussed, it is not normal or proven, and is certainly in the wrong direction to the upward refraction or sinking that we commonly observe. This roughly agrees with my earlier calculation as shown here, which confirms that the mountains are far too low for the globe model. Let's now turn to the flat Earth model. This is similar to the angular size argument in the previous video, except it is more sophisticated due to its use of linear perspective, which gives a mathematical model for how lines converge to a vanishing point. As usual, this looks like a compelling argument that the flat Earth model doesn't fit with reality, but how accurate is linear perspective? Nothing ever actually vanishes at the vanishing point. Instead, all objects remain fully resolvable. However, there have been many artists over the centuries who have doubted its realism. They say that the perspective, although mathematically correct, is distorted and unnatural.
Allow me to summarize. That refraction, which is not normal or proven and is certainly in the wrong direction. Now, is that not an oxymoron statement? If it is not normal or proven, then how can it certainly in the wrong direction? It has to be proven some way to be certain about any direction, right? I will ignore the word normal. The fourth clip had a bit of a response that basically states that many artists do not use linear perspective to draw, so that 3D modeling is incorrect. Due to the nature of the beast, I do have to jump between different topics. There is quite a lot going on here. Let's start with the easiest point, which gives me a chance to share my love for this artist to you. I absolutely love this guy. MC Escher was a Dutch graphic artist who made mathematically inspired woodcuts, lithographs and mezzotints. I'm super hard pressed to say which drawing I like the most. There are so many. But the one I would like to show you is this one. This simple drawing, ascending and descending. This amazing staircase is a physical impossibility, and yet Escher makes it look totally possible. My point is, what methods artists use or do not use has nothing to do with reality. Next is vision and what is resolvable. For one of my earlier videos, I took some photos of two electric tape that I put on a street lamppost. As I know the width of the tape, the gap between my camera sensor details and the focal length I have used, I can calculate how far my camera is from those tapes. What I really wanted to do was to show that when we are fully zoomed in, those tapes appear bigger, and in pixel size, both top and bottom tape takes the same space, just as expected. When I start zooming out, they start getting smaller till the point when they are no longer visible. But during this whole process, both top and bottom tape was the same pixel height, and the ratio between the tape and the gap between remained constant, meaning the gap was shrinking at a linear scale. Once it was no longer visible, I could have swapped in a bigger zoom to bring it into view and again have the same result of the ratio being the same. The angle those tapes makes to the observer may it be optical lens or our eyes. It has to be greater than whatever the minimum resolvable angle value for that optic to be resolvable or visible. Simply put, when the angle is less than what our eyes and brain can register, we no longer see it or can resolve it. If I had infinite plane and an infinite zoom, I could pull back and get the same ratio regardless where I am. Of course, unless something else comes into play. This whole test was to show when ship goes over the horizon, it disappears from bottom up and the ratio changes. As I demonstrated, it can only change with another variable. I don't know, like the curve? A computer 3D model behaves exactly the same way. There is a minimum it can draw. Say that minimum is one tiny dot. So when an object is calculated to be less than that minimum draw size, it's probably not drawn. It is also an infinite plane and infinite zoom. Just to hammer the point home, without bringing any other variables into play, perspective dictates how small the object appears from different angles, but once a viewing angle is established, changing the distance would retain every ratio. The scale between tower bottom to the top dome and the top dome itself would remain constant. In our Earth, we normally bring in two common factors. First one being the curvature of the Earth. This explains why the boat mark ratio changes as it is going over the horizon, or disappears from the bottom up. Next one is the refraction. Almost all of us were taught about this by putting a pencil in a glass, or maybe looking at a fish in the pond. Here I'll make a promise. If I ever get to 1K subscriber, I will personally go to Winter Hill and take time-lapse videos throughout the day. My guess is during noon I should have the least refraction. And being a night owl, I'll most probably miss sunrise. During sunset, I should get the most refraction, hoping the weather remains more or less the same and hopefully not with any haze to begin with. How about until then? Well, on my Mount Carnegie video, I approach it from the sun point of view and what happens during those specific months when you can see this visual phenomena. Fellow YouTuber Sly Sparkin handled it differently where he showed the peak matching up where the bottom was missing. Link is in the description. How does that prove my point? Well, suppose there is no curve and that mount appears smaller because of refraction in opposite direction. Well, in that case, over 8,000 feet of the mountain is missing, where the peaks are intact. So this refraction completely compressed 8,000 feet of the mount and left the top couple of hundred feet completely intact. I will admit, this is not as good as my proposed photos. For refraction, I will be lazy to begin with and play my old video. First of all, what is refraction? Well, light while moving from one transparent medium to another would bend, and this is what we call refraction. The formula used to describe the relationship between the angles of the beam was first accurately described by the Persian scientist Ibn Sahal at the Baghdad court in 984 and is now known as Snell's law. Imagine a perpendicular line from the surface of these two medium, and that line is called normal line. And the higher the angle difference is between the normal and the light beam, the greater the refractive angle is. If the light happens to hit at 0 degree, then there is no refraction. Now, the density of our Earth's atmosphere is uneven. It decreases with increasing altitude. Light from celestial objects, including the sun, therefore refracts multiple times when it enters the atmosphere from space. Putting this all together, light rays that travel straight down do not bend, while rays that enter the Earth's atmosphere at a shallower angle get refracted and bends towards the normal, roughly following the direction of the Earth's curvature. Which means that celestial objects in the zenith position directly above you appears in the correct position, while objects closer to the horizon appears to be higher up in the sky than they actually are. This effect is especially more prominent for objects that appear close to the horizon, such as the rising and setting sun, because the light rays enter the Earth's atmosphere at a particularly shallow angle. Thanks to refraction, we may actually see the sun several minutes before it actually rises in the morning and after when it sets in the evening. Hogwash, you say. Can we see this by ourselves? Well, some examples of atmospheric refraction would be, if you're sitting around a campfire, the person opposite you would appear to shimmer. This is due to refraction passing through the hot air, which is also rapidly moving, and thus its optical density is continuously changing. So the person appears to shimmer. No campfire handy? No problem. This is a similar cause of stars to twinkle. In stars' case, the physical conditions of the atmosphere keeps changing and the apparent position of the star fluctuates, which gives rise to the twinkling effect. Whereas planets, well, compared to stars, they are much closer to Earth. We can consider planets as a collection of large number of point-sized sources of light. The net variation in the amount of light reaching our eye from all the point sources will average out to be zero. Thus, on the whole, the brightness of a planet always remains the same and does not appear to twinkle. Atmospheric refraction is why Sun appears bigger during sunset and sunrise, and also the reason why it appears flattened during those times but circular at noon. If you can accept the fact that is refraction, then the mountain scene makes sense. When you see the sun touching the horizon during sunset or sunrise, in actuality, the sun is really below the horizon or already at negative axis. That refraction allows us to view part of the sun that is blocked by the curve. On top of that, I can only add, as light is bent in the direction of the higher density, and the density of our atmosphere generally decreases exponentially with increasing altitude, from our understanding of refraction, it doesn't work the way exploring the plane explains. Why do we use a standard atmospheric value? Well, because it depends on the current atmospheric conditions along the light path and therefore fluctuates on the way. Imagine you have perfect shot lined up and then a jet ski passes by, sprinkling water in the air. The dance light would be playing in that is not predicted in any model. Thus, we use an average value based on altitude, temperature, and such.
However, this is very misleading. The problem with most research regarding light refraction is that it almost always begins with the false premise that the Earth is spherical.
Absolutely incorrect. Refraction does not care, and the entire calculation is based on a plane. We see amazing display of refraction in a tub, no curvature needed. All it requires is materials with different density. Our atmosphere has a gradient density, and as Earth happens to be a sphere, this atmosphere follows the same curve, and thus the result. Refraction has no such premise like Earth is spherical. Finally, this video also talks about Mirage, so maybe we should gently cover it. Take it off, old me. But one final thing before that, and this is super cool. The floating city of China. This amazing video was wrongly attributed to a type of atmospheric superior mirage called Fata Morgana. So what is a mirage? Well, this is the optical illusion when light is bent by layers of different temperature air along the Earth's surface and causes displaced object. It can be distant object or the sky. So whatever we are seeing actually exists. So when we see water mirage in desert, it is really part of the sky displaced. Obviously, we can't leave it at that. When object above the horizon appears under the horizon line, well, we call it inferior mirage. When object from below the horizon line appears above the horizon, well, it's superior mirage. But Fata Morgana is amazing to look at. It is an extra shimmery, multi-layered type of superior mirage that doesn't happen very often. This also makes distance boats seems to hover above the ocean surface. How cool is that? Unfortunately, mirages can only happen very close to the horizon line. Darn. Well, it's because that view at which the refractive properties are most prominent. Unless I have misunderstood it, exploring the plane is saying, as the light bends towards denser material and dry air is more dense than water vapor, light will bend in a way that causes inferior mirage. Usually on an inferior mirage, you'd see it upside down. By some other photos by the same photographer who took a Chicago skyline photo, you can see example of this inferior mirage. To be brutally honest, I can't disprove that an inferior mirage hitting all these landmarks at the correct angle and A. Not creating an upside down image, and B. Totally covering the bottom. If I have anything new to add to what have already been discussed, I'll make another video. In the meantime, if you do want me to go and get a day time-lapse photos, or maybe 2 if I reach the goal of 1K sub, please make sure to subscribe and maybe even recommend it to friends and family. Well, this is where I'll end this video. I do hope you have enjoyed it, and thank you for sticking around till the end. Being a small channel, I do appreciate your like, comment and sharing if you choose to, and it also helps with the algorithm. Wherever you are, have a safe day. Signing off.
Try.